This problem we are going to talk about buffers. The problem reads, if a buffer is created with HA and A- at a 0.3 concentration each, where the pKa of HA is 8 and the pH of the buffered solution is 8, then 0.10 moles of HNO3 is added to the solution. What is the resulting pH? We know that for buffer systems, there has to be a weak acid with its conjugate base. Here that we're using a weak acid since the pH is going to be at 8, and it is right here. Then we're going to add HNO3, which is nitric acid, and it is a strong acid to the solution. Go ahead and draw out the HNO3, and it will completely dissociate into H plus and NO3 minus. Now we also know that we have an equation that deals with pH, Kas, and moles. So this one would be pH is equal to negative log of Ka plus log of conjugate base over the acid. Now we would just have to plug everything in. We know that the pH is equal to negative log of Ka plus log of conjugate base over acid, and we are given 0.3 moles of each in the buffer system, where the pKa of HA is 8 and the pH of the buffered solution is 8. Then 0.10 moles are added to the solution of nitric acid. So we have pKa is 8. We know that the pKa is equal to negative log of Ka. So if we weren't given the pKa, this is how we would find this part of the problem if we weren't given pKa and we're only given Ka. But since we have pKa, which is the same thing as this, we can just replace it. So pH is equal to 8 plus log of the conjugate base over the acid. It is said that it is 0.3 for each, so we put 0.3 over 0.3, and this is where the nitric acid comes in. So it is added to the solution, to the acid, it is added, and we will subtract it from the conjugate base. This into your calculation, you would get a new pH of 7.69, which we can say 7.7.